I'd like to welcome you today to the Monday afternoon program of the 19th Century Charitable Association. And welcome to all of our members and guests. Our mission is to strengthen our community through learning, giving, and sharing our landmark building. My name is Ralph Lee. I'm a member of the Science Committee. They are the sponsors of this program today, and Susan Roberts is our chair. Our speaker today is Dr. John Tandrich, who is a native of Austin and Galewood neighborhoods in Chicago. He's been an Oak Park resident since 1969. He attended St. Giles School, Fenwick High School, and Loyola University, where he earned a Bachelor of Science degree in archaeology. He then roamed the Midwest, studying at the University of Iowa, University of Missouri at Columbia, and the University of Illinois at Urbana-Champaign, where he earned a PhD in natural resources and environmental sciences. He worked for the late wetland expert, Dr. Donald Hay, for 30 years and now teaches physical and environmental sciences at Wilbur Wright City College of Chicago. He's also an active member of Unity Temple Unitarian Universalist Congregation here in Oak Park. So please welcome Dr. John Tandrich.
Thank you very much. I want to thank Ralph for that very nice introduction, and thank you very much for the really lovely lunch today. Well, that fortifies me for the talk. Anyway, I'll tell you a interesting story. I was born in Austin, and some of you also had born at the old St. Anne's Hospital, which doesn't exist anymore. And I went to St. Giles and then Fenwick High School. And it was at Fenwick High School, they started an archaeology club there back when I was a junior in 1966. And the instructor brought in a book by this man. His name is J. Harlan Bretz. He was a professor at the University of Chicago. I found out that he was an associate state geologist, and he and his students produced the only detailed geologic maps of the Chicago area. Of course, as a junior in high school, I read the book, and there was a lot of interesting stuff in there, but I didn't understand much of it. But I started collecting maps of different things, and because they were interesting to me. And here's a map from 1832 showing the original area that became Oak Park. I mean, I don't think there's hardly anybody here yet. No. But you see the thumb coming up into Oak Park. That marks the area that was where the very large oaks are that we reported on in the Wednesday Journal article. Gina Orlando wrote about the very large oak trees. Some of them are 300 years old, I think. And I sampled the soil and found that the soil reflected the fact that it was originally a forest. And anyway, so that's another piece of the puzzle. And then when eventually I got around to, I've made that great circle route from Loyola here to the University of Iowa in Iowa City to the University of Missouri in Columbia, back to the University of Illinois. And I was studying glaciers. I'd gotten interested in the glacial geology, particularly of this area, as I was inspired originally from Brett's book. And the man who first proposed that there was a great ice age is this man. His name is Louis Agassiz. Louis Agassiz, and he was recruited by Harvard University to come to the United States in 1847 to be their top dog in natural history and geology. And he traveled all around this area and reported on in 2 huge volumes from around 1850 on the natural history of this area. And Agassiz, in fact, Agassiz was from Switzerland. And it was amazing. He started studying the glaciers in the Alps, and the people didn't it wasn't scientifically proven that the ice actually moved, but he showed by his studies that it does. And because people were really wondering about these boulders that were scattered around the area of Northern Europe, they were rock type that they were from a different area, and he proposed that the ice carried that stuff, carried those boulders, and when they melted away, left them behind. And here in Oak Park, some of these can be seen. I've seen some very interesting boulders. I won't go into them, but I've seen them scattered all around from the result of house construction. And anyway, Agassiz students went on to found the modern sciences and disciplines of geography and geology and the study of landscape, which is called geomorphology, up at Harvard. So his students were very prominent, and they influenced and taught many people. A man who purported on the soils of Illinois at the 1893 Columbian Exposition was this man, Frank Leverett, who went on to be a glacial geologist. And he walked over 100,000 miles in his career. He had a meeting. I think he had to go from Des Moines to Madison, Wisconsin, so he walked there. But you see, here's one of his maps. He was very careful, and he inspired other geologists in their work. In fact, I had a copy of his big, a huge book called the Geology of the Upper Great Lakes. And in it he had some, well, here you see some of the stage of the Great Lakes as they were forming, and he worked on their evolution, and he said that the ice sheets came down from Canada and scooped out the basins. And he inspired other geologists. Let me show you a map of Oak Park in 1902. Yeah. See this? There's the ridge that comes down through Taylor Park, through Scoville Park, and over to Mills Park. Yeah. When I saw this map, I was really interested in what this meant. And by the way, I suspect that many of you are from Oak Park, and I have to tell you, it's a little anecdotal thing here. When the first time I saw Taylor Park, I remember as a kid seeing a gazebo in that park. It's not there anymore. And my grandparents and mother and uncle referred to that park as Skeleton Park. And I asked archaeologists, and historians what the deal was, and nobody knew. Do any of you know? My guess is that when they were digging for that gazebo, they found Native American burials. That's what I think, but we don't know. But it is interesting. I have wanted to ask people about this for years. But that's an interesting folk term for the park. And so I was wondering what created these features, particularly that long, sinuous ridge that you see, what I just pointed out. And I had a chance at the University of Illinois to study with some of the best glacial geologists in the country. And they, one of my professors had actually been in a glacier in Iceland. And this is what the area looked like about 20,000 years ago. It was all covered with ice. And notice the dark blue color. That's the ice near the bottom of the ice sheet. The weight of the ice has pushed all the oxygen out of the ice, and it turns blue when that happens. And so the people at the Geological Survey were very certain that our area looked like this. In fact, they came to the conclusion that this area was very much like Greenland is today, covered by the ice had formed a big dome over eastern Canada, and the ice kind of crept out like the blob, It moved very slowly outward from the center near Labrador. And on top of that, there was another center of ice like this in the north center part of Canada called the Keewatin ice sheet. And the two moved south over our area. You know, they say that the ice sheet, if both Greenland melted and Antarctica, it would raise the oceans about 200 feet. And that's a definite possibility. See, Antarctica has two ice domes, very much like the ice that came down from Canada 20,000 years ago. And there's a lot there to melt. I don't know, the question that we all asked was, how long is it going to take to melt all this? And we don't have a good answer. But you can see the West Antarctic and East Antarctic ice sheet, with the East being the highest. I like that. There's the South Pole, and they have northeast of that, the pole of relative inaccessibility. I bet it is. One of my professors actually got to go there and study down to Antarctica. And there are some valleys that are ice-free and have water in them that's not frozen because it contains a high amount of calcium carbonate, you know, which is the more expensive ice melter. We usually use, you know, sodium chloride, which is regular salt, but sodium chloride, it works to a lower temperature, and that's why the those ponds that they saw were unmelted. Because even at 60 to 80 below zero, because of the calcium carbonate content. Now, let's see. Thanks to Professor Agassi's original research, we see that snow transforms to glacial ice very gradually as the air is compressed out of it by weight of the ice above. And see, it becomes what the Norwegians called firn, which is 20 to 30% air. And then lastly, it's the ice itself. And so the ice can be thought of as a mineral at that stage. And here is a thin section of ice under polarized light. It looks like a rock, which is composed of minerals. Each of those would be a separate mineral, but here we have different degrees of ice compression, making this multicolor. It's too bad it would melt very quickly. They have to keep the ice below zero usually. That's 0 Fahrenheit. I hope people would like to work in the cold. Let's see. Okay. See, there's the clean blue ice. That is so amazing. And ice can be clean. See, that kind of looks like Green Bay has limestone pebbles in it that look like the bottom of the look like the bottom of this blue ice picture. It's really interesting. The one on the right, the fellow, it's dirty ice. Dirty ice, you know, contains a lot of mud and sediment and that sort of thing. Many of you have gone to see Glacier Bay in Alaska and have gotten to see the ice peel off the glacier and crash into the ocean. How many people here have been there? Wow. I haven't, but I have been to the it's called the Columbia Ice Field in Alberta, Canada. It's a glacier, a mountain glacier, and that was the most amazing thing. They all gave us a cup and told us to dip it into the holes where the ice was melting, and that was the best tasting water I've ever had. It also didn't contain very much lead, as our water can. And also the big ice sheets in Greenland and Antarctica are calve off these big glaciers. I'm sorry, icebergs. And they're pretty dangerous, as the Titanic found out. Because 90% of that glacier, that iceberg there, is under the water. And that is really remarkable. If any of you have walked around that area around Glacier Bay, you may have seen these what are called glacial striations. In fact, they're around here too. Up in Wisconsin, up near Green Bay, is a quarry called Wedren, near a town of Wedren. Not Wedren. Geez, what is it? Oh gosh, well, I can't remember the name right now, but I think it's near Two Rivers, Wisconsin. The glacial material that was carried by the ice, as it moves along, it not only scratches the rock, but it will freeze to the rock and rip it up and incorporate it into itself, kind of like the blob again. And up there, the rocks, as the ice incorporated into itself, came from the southern shore of Lake Superior. It's the Jacobsville Formation, which is a red sandstone and siltstone. And I'll be talking about it again. it incorporated that stuff, red colored. In fact, you can see it in western McHenry County along the Kishwaukee River. The sand and clay that they're mining along the river are red. And I'll show you some examples of that color. Very distinctive. No, what was I going to say? Yeah, the ice incorporates rocks. It rips rocks up. And that's what leaves the grooves or the striations in the rock. Boy, I wish we had good striations around here like this. Whenever we encountered striations, the geologists, the glacial geologists, would get their compasses out and run around and start recording the degrees off of magnetic north. They wanted to know exactly where the ice was coming from. And they took several measurements. Another common feature, you can tell that a valley had a glacier in it because it's U-shaped. Yosemite, Yellowstone, Glacier National Park, and some valleys along the Great Lakes are U-shaped. Those that are just carved by running water are V-shaped. And so that's really interesting. Up in Canada at Banff National Park, which is the Canada extension of Glacier National Park, are huge U-shaped valleys. And here is what Professor Agassiz saw in the Alps. These lonely boulders, which the French named erratiques, wanderers. And, I mean, they're really big. The ones around here aren't nearly as large. But up further, they're almost as big as this one, with the fellow standing on top of it. The glacial erratique. And here's what the material, ground up material that the glaciers deposit. They melt away and deposit this stuff. It's glacial till. It's clay, mainly clayey, and has rocks in it of varying sizes, and including the one, that big erratique you just saw. The glacial till here is gray, a dark gray. And there's a lot of this around here. Out near Crystal Lake, we found a lake deposit. You see the layers called varves. They represent yearly deposits of sediment. And when the lake freezes over, there is no sediment deposited. That was really amazing. Working for Dr. Hay, you know, he always wanted to study, you know, call in the experts to study this stuff. And sure enough, a team from the Illinois State Museum came up, and from the Illinois Geological Survey came up to study this lake deposit. And they took samples every centimeter. And that was about, about 50 feet thick. I admire their patience. But the pollen expert and the person who, remember the geologist who studied lake sediments, were both working on it very diligently. Radiocarbon dating put the lake at 23,000 years ago, when it was a lake just in front of the ice sheet. There. I'm sure everybody's heard the name moraine. There's a moraine valley, moraine park, state park. Here you see them. They form, well, this is in the Alps, but the same process is the same. As the ice moves past rock, it incorporates it, grinds it up, and incorporates it in the edge of the ice called lateral moraines, and in the middle called medial moraines. Hey, it did it. And at the end of the ice sheet is what they call the terminal moraine. You can see that out near Marengo. The Marengo Ridge comes north out of Wisconsin, goes by Marengo down to Bloomington Normal. Goes by Peoria, this side of Peoria, by Bloomington Normal. And I'll show that to you in a minute. But this shows you how it forms. Left behind, the ice melts back. Yeah, that's an interesting thing. The ice never moves back. It always melts back. It moves forward, but it melts back. There. And sometimes the weight of the ice squeezes the glacial chill into large mounds that are teardrop shaped. There are over 14,000 of these up in Wisconsin. There is a field of them west of Waukesha, northwest of Milwaukee. They're called drumlins, and they have the same shape here as they do in New York and over where they were first described in Norway. And also, here's some more landforms. Oh, come on. No. Inside the ice, rivers and streams form and flow. The Des Plaines was such a stream. And as a byproduct, it carried sand and gravel that had melted out of the ice, carried by the streams. Out near Dominican University, we had a chance to see sand that was deposited by the original Des Plaines River 14,000 years ago. And I could kick myself for not looking for artifacts in that sand. They could have been there. That's a real good opportunity. But out near Elgin is one of these, what they call esker. It's a stream that formed inside the ice and basically carried a lot of sand and gravel, and then the ice melted away and left the sand and gravel in place. And it did the same with the holes in the ice, form large hills called kames. There are a bunch of these kames near Waukesha. They're mining them for their sand and gravel. And they sometimes pieces of the ice break off and are left as stagnant, what they call stagnant ice. And the chain of lakes are kettle lakes. And in eastern Lake County, I mean not eastern, western Lake County, there is a whole bunch of these kettle lakes like Diamond Lake, Third Lake, and you look at the map and you see how round they are. They're, for the most part, they're kind of rounded. That's the hummocky topography is characteristic of the bottom of the ice. Yeah, and north of Des Moines, Iowa, you can really see that. Its ice was a little younger than here. This ice was 20,000 years. Theirs was about 15,000 and laid down a very hummocky topography. There you can see 3 episodes of glaciation. The most recent is shown in green. That's called the Wisconsin episode. It's about 20,000 years. The blue is Illinoisan, which is about 130,000 to 320,000 years. And the pink, which I worked on, is called pre-Illinois. And it is several glaciations going back to 2.5 million years ago. I mean, really old. When I started learning about this stuff, they only thought there were 4 glaciations. The Big Ten came first. I mean, no, the Big 8 came first. Nebraska and Kansas. Then came the Big Ten, Illinois and Wisconsin. Well, they discovered in a quarry near Omaha that there were evidence of about 17 other glaciations, all older than the Illinois. And so that's how that came to be. So anyway, my work in Missouri was really interesting. I got to see that oldest glacial till from maybe as far back as a million or million and a half years. But I didn't find any bison or mammoth or a saber-toothed cat, nothing like that. I only found petrified trees, which were, let's see, they occurred, they were growing on top of the bedrock, and they mainly contained pyrite. They were made of iron pyrite, which had replaced the wood. That was really interesting, but you couldn't carry anything like that because it weighed tons. So anyway, let's see. There. Now you see the a map showing the end moraines. The end moraines, and there's the terminal moraine of the ice sheet. See the red up near Chicago is what they call the lake border moraines. And behind every one of those curved areas that have a moraine, there was a lake behind it. And that was really interesting. The whole area was covered with lakes. Here's what I want to show you. See the pink area up at the top? That's a moraine, Park Ridge. And that is very obvious. It forms the sledding hill at Reese Park is the best example of that. And North Avenue, that's the end of it. So it's great sledding on North Avenue too. And see, there's a piece of the moraine down near Blue Island. And see, Blue Island is an island. It's a morainal remnant. Let's see. Here is a brief point of view how the lakes formed from 14,000 years ago to 4,000 years ago when they assumed their present position. Now, it's a good thing this is going to be posted, because the next map, I won't be able to show it very long. This is the map I made from Dr. Bretz's 1936 map of this area, showing all sorts of features, including the big sand ridge that it goes through Taylor, Scoville, and Mills Park. And right behind it, there is a big flat area that contains the sand from the original Des Plaines River. And that's what people used to use for drinking water in the 19th century out here. So take a look at this online then, please, folks. There are other things that I could talk about for the rest of the afternoon, but we have to move on. Here is a schematic of showing the most prominent features. And east, right here, the ridge you know, there's going through Scoville Park, and then east of that is a ridge that crosses over Roosevelt and Austin. That's that's another phase of the ancestor of Lake Michigan, which is rightly called Lake Chicago. And that lake was huge. I showed it. I forgot to even mention it. I'm so familiar with it, but it's all the features you'll be able to study in detail online. See, and here's what the clay looks like. 4 feet of dark clay, and there is places, and there was out there at near Dominican University, a band of red clay from Lake Superior. And you could see it, the reddish color.
Do we have time for questions?
Yes. I see. Does anybody have questions? Oh, thank you. Yes.
My question is, given that you have focused on the past, but I wonder, with global warming, do you have any prediction of what might happen to Lake Michigan and this area as we have global warming?
The question was, is this area going to be affected by global warming? Not very much. I mean, in terms of the land being affected, we're at 585. And so the rising sea level will not get up here. It may get to Lake Ontario, I think. It may get that far, but Niagara Falls will stop it. Yeah, the St. Lawrence Seaway will get really big. And so that's a good question. Yeah, yes, back there.
Right here. Here.
I'm sorry. I'll get you next. Yes.
I'm a volunteer with the local history museum. And one of the things we have is some relief maps that Isabel Wasson did in the 1940s. And I always have the sort of spiel I do about why Chicago is here and why Oak Park is here and why the Spit is here. And I want to be correct. On that, it shows the Park Ridge moraine, and it shows the Oak Park Spit. And one simple question is, when did the ground we're standing on appear above water?
I'm sorry, what?
What year approximately did this become dry land?
Oh, about by 10,000 years ago. I found over near Unity Temple, I found a Clovis point, meaning that there were people here about 12,000 years ago. I mean, not a lot, but a few. But it was that dry enough for them to be here.
Now, in those days, would it have been some high spots surrounded by water, or was it pretty much all dry by then?
It's the interesting thing is that there are ridges, small ridges going from here, from the Oak Park Spit, the big sand ridge through Taylor and Scoville and Mills Park. There are small ridges about 2 feet high going east all the way toward the lake. A lot of them have been destroyed during house construction, but many of them are still there, and you probably have seen them. You see these very small ridges, and they all have artifacts on them. I've looked.
We have time for only one more question, and afterward, everyone is invited downstairs to the dining room for more questions and conversations.
Well, I'll get you. There was a lady in the back. Yeah, the lady in the back there. I know. I'll get you.
Thank you. I'm wondering why our part of the area is flat, yet, and as you go north, it's hillier. There are moraines, and there's one along Sheridan Road, around Highland Park or Glencoe, for example. But, it's mainly so flat. And then as you go north into Wisconsin, you get Kettle Moraine, it's hilly. So I've always wondered about that.
Yeah, the area that's flat was, the places that were flat were the bottom of Lake Chicago in its various stages.
Thank you very much, John. Thank you very much. And
Okay.
we are going down, and there will be more questions.
Okay.